welcome. This is going to be a mini lesson on trophic levels as it relates to energy flow through a community. So let's look at trophic levels. As we learned in a previous video, trophic levels refer to a hierarchy of feeding or eating within an ecosystem. So it's no surprise that trophic levels are based on a given food chain or food web within an ecosystem. The basic levels that we will use to describe the trophic levels in our ecosystems will be producers, which will be eaten by the primary consumers. Primary consumers will be eaten by secondary consumers, which will be eaten by tertiary consumers, and finally quaternary consumers. And so it is very linear. It's based on a given food chain as we pull it out of a food web. So on the screen you can see there's an example of a food web that you might be able to find here in Minnesota. I've highlighted a couple different pathways through this food web, which are individual food chains within this ecosystem. Now what I'd like to do is to use this as an example of how we could label the trophic levels within this ecosystem. So we'll start with the lowest of the trophic levels, and that it will be the producer level. That's where all the plants and other producers are located for an ecosystem. Remember, producers are those that take the sunlight and turn it into chemical energy for themselves to use, and turns out for the other organisms in an ecosystem as well. So I'm going to take my producer, I'm going to label it right there. There's some grasses and some grains and some trees there, and those are going to be our producer level. Now I have three highlighted food chains. We'll start here with the pink food chain right here. The producer gets eaten by this deer, which gets eaten by this mountain lion. So the way the trophic level will be, producer gets eaten by a primary consumer. So I would be able to say that the deer in this situation is a primary consumer. Now, typically speaking, most herbivores will always be primary consumers because all they can eat is the producers. Then the deer is hunted and eaten by the mountain lion or whatever this large cat is here, and we're going to label that as a secondary consumer. Now the large cat up here might end up being a tertiary consumer in other parts of this ecosystem, but this particular food chain ends up as a secondary consumer, and that's the end of that particular food chain. So that's where we end as secondary consumer. Let's take a look at the light blue one. We'll do the same thing. Producer gets eaten by a grasshopper here. The grasshopper is a primary consumer. The primary consumer is eaten by the bird here, and that's going to become a secondary consumer. And the secondary consumer then is eaten by another one, which is our cat again. And so the cat becomes a tertiary consumer for that particular food web. All right, and the yellow one, same thing. Producer are the plants that produce these nuts and berries, which are eaten by the squirrels. The squirrel is going to be a primary consumer with the primary consumer label on it, which is eaten by the turkey vulture, which has now become our secondary consumer, hunted and eaten by looks like a wolf, might be a coyote, which is the tertiary consumer, and then it is consumed by bacteria after that poor coyote or wolf is dead. And that's the way we would be able to label the trophic levels within this given food web by individual food chain. So, the real power really comes with trophic levels, comes with when we put these in pyramids, and we can show some very distinct and unique relationships within ecosystems based on our trophic levels. Remember what a pyramid is. A pyramid looks like this. It's a geometrical shape that has a wide base and a narrow top, and you can see that pyramids have been used ever since Egyptian times. And so that's what a pyramid is. And when we look at the pyramid, if we calculated the volume of this lower layer versus the top layer, there's a big difference in volume. So as we start looking at that, we're going to use a pyramid. We're going to set up our trophic levels in pyramids to help us see the relationship of relative amounts of energy or relative amounts of matter or numbers of individuals, and we're able to use some comparisons that way. So let's see how this is done. Here's our trophic level pyramid in a two-dimensional form rather than a three-dimensional form. So we have to kind of envision this being 3 dimensions. We're going to use the mass, the energy, the numbers kind of all kind of together to create this trophic level pyramid. You'll see how it can be used in any given example. So at the bottom is the most massive. It has the most numbers of individuals, has the greatest amount of energy available. And if you think about this in 3 dimensions, it has the greatest volume at the bottom. So as we look at this, that's where our producers will go. Okay, so our first level is going to be the producers. And if you look at the number of individual plants that is necessary to support an ecosystem, you will be able to see that in terms of numbers. They contain all the energy as it starts, or if we were able to kind of take and mass the amount of plants that are there, they would have the most mass as well. Well, the unique part about the base of the pyramid is that none of the rest of the levels of the pyramid can be any bigger than the bottom base. It's the foundation it's all built upon. So as you look up, each successive level is going to get smaller and smaller in terms of volume and size. So this next level can't, in terms of numbers or in terms of energy or in terms of mass, can't be any bigger than the producers. The producers are going to be the biggest level. So this next level relies on the producers directly, and that's why it's right on top of it. So it's going to be those that eat the producers. We call them primary consumers. Primary consumers could be organisms that we label, or consumers that we label herbivores or maybe omnivores. We could probably even slip in a little decomposer in there, depending on that ecosystem and the situations within that ecosystem. So the producers were eaten, were established, and they were going to take in the sun, and then they were eaten by the primary consumers. The primary consumers can't outnumber or can't outweigh, can't out energy the previous level. That's going to go for the same relationship with the level right above it. The level right above it are those that are going to eat these primary consumers. In this case, grasshopper will be eaten by a toad, which are secondary consumers. Now, secondary consumers are going to be our carnivores and our omnivores typically. We can also slip in there a decomposer to go along with it as well. As we've seen so far, the numbers at each level of individuals, the amount of energy at each level has really gotten smaller. If you look at the number of secondary consumers in any given ecosystem, there's a lot less of those than the primary consumers. It's harder to get the food. The amount of energy available to the secondary consumers is much less than that available to the primary consumers. So that relationship is being played out as we move to the next level as well, which is going to be those tertiary consumers that we talked about. These could be carnivores, these could be omnivores, there could be decomposers at this level. It really kind of depends as we look at the ecosystem. But they too, they're going to need to eat a whole bunch. A lot of times eating things larger than themselves. The meals come at sporadic times. So again, harder to maintain their own mass. So their mass at this level is much decreased, considering they're relying on the secondary consumers for their food. And we finally reached the top of the pyramid, which is going to be our quaternary consumers. Our quaternary consumers typically are going to be just decomposers. They're the ones that are going to be left with whatever energy is left in the tertiary consumers, whatever energy, whatever mass, whatever materials, and they're responsible for using it all up, breaking it back down so that this can begin again elsewhere in the ecosystem. Typically speaking, they break it down into the materials, back into the earth, which then are reorganized by the producers. The energy simply is just used up. The one relationship we do really want to point out, though, is this idea of how energy moves up the pyramid and how it really truly dictates how many and how massive each level can be in an ecosystem. Obviously, the producers have the advantage because they're able to take in the sunlight and until the sun disappears on us, they will always be able to get all the energy. And so they can start off with 100% of the energy converting it. Now, it does get transferred to the primary consumers. Through that transfer, not all the heat, not all the energy ends up in the primary consumers. So the primary consumers only have 10% of that original energy available to that level. Now, what happens there in this loss? I'm going to just put an arrow here to indicate that there's some energy lost. You lose that 90% of it is lost in that transfer process, and it's lost as heat. So heat is that wasted form of energy. So we don't, as we move up the pyramid, we're going to lose our energy to the point where there'll be no more at the end. We have to keep adding it back in here at the beginning. Although we're not losing, it's not disappearing, it's just getting changed into a wasted form for living organisms, and that will be heat. Same thing goes in this transfer. Of that 10% that's available to primary consumers, well, as secondary consumers eat those primary consumers, they're going to, again, there's going to be some energy lost. Again, 90% of it's going to be lost as heat. So 1% of that original energy that started down here at the producers is actually available for the secondary consumers. Again, 90% is lost to the next transfer, all the way up to the quaternary level, where it's 0.01% of it left, and they finish it up. So anyways, there's 0 left here at the peak after the quaternary consumers are all done with it. But we call this rule the 10% rule, or the 90% lost rule, or however your teacher likes to put it. But in any case, within these transfers, either 10% is available, or 90% is lost, however you want to look at it. And that's where we're going to end. This mini lesson was about the trophic levels, how we can pick those apart within an ecosystem, and it was more specifically food webs and food chains, and then the relationships that we can extract from it using the trophic level pyramid.